what determines a function to be a polynomial? Okay. In general, an expression that is a real number, variable, or a product of a real number and variable, okay, with number exponents, whole number exponents, and that's key. Whole number exponents. Okay, that determines if it's a polynomial. So, is known as a polynomial. Okay, a polynomial is monomial, which is one, or the sum of monomials, so it could be more than one. Standard form is always written in descending order from highest exponent all the way to constant. This is another key term. The highest exponent of a variable is called the degree. The highest exponent is called the degree. Okay, so here's an example of a polynomial. What is the highest exponent? Yep, 3. So this would be a degree of 3, because the highest exponent. Okay, but we also have names for these. Okay, so anytime it's asking to classify a polynomial, you're looking at two things. The degree, which is the highest exponent, and you're also looking at the number of terms. Okay, so for example, the number of terms in this first example, how many do we have? How many terms? 4. Okay, this would be 4 terms, and that will be a classification as well. Okay, so if you have a degree of 0, that's a constant. This is just a number value. So for example, 5. If you notice, there's no x attached. Okay, it's just 5. Or 3, or 2. Okay, the number of terms in this example is 1. So the name that we use for the number of terms is monomial, meaning 1. Okay. If I have a degree of 1, okay, that is called linear. An example of that is x plus 3, or just x. Okay, so you can write 2 examples here if you want. Okay. So for this example, x plus 3, how many terms do we have? 2. What would the name be? Yeah. Binomial. Good. Okay. And one that we're familiar with. Yeah, Camilla. X would be a monomial, just x by itself. So this is an example of a monomial, but it will be determined a linear function. So there's 2 things going on here. There's name by degree, and there's also name by number of terms. So you could have a linear monomial, you could have a linear binomial. Okay. Constant is only going to be a monomial anyway. Quadratic can be a number of things, right? So quadratic has a degree of 2. An example, x squared plus 3x plus 4. Or 5x squared plus 2. Okay? Anytime you have a degree of 2, that is a quadratic. Okay? For this example, how many terms do we have? Nick? 3. So what do you think that would be called? Emily? Good. All of you. Good job. Trinomial. Excellent. Okay. Now if we have a degree of 3, okay, that's a cubic. So for example, x cubed plus 2x squared minus 3x plus 1. This is just one example. Okay. Okay. If we have a degree of 3, it's a cubic function. So these names we have to know. Okay. How many terms do I have here? 4. So if it's 4 or more, it's a polynomial. Okay. If we have a degree of 4, which is called a quartic, x to the 4th minus 81 is an example. If we have a degree of 4, it's called a quartic. How many terms do I have here? 2. So what would I classify that as? Binomial. Good. Okay. If I have a degree of 5, it's called quintic. Okay, quintic. X to the 5th plus 3x minus 10 is an example. How many terms do I have here? 3. So what would that name be? Trinomial. So anything higher than 5, okay, so for example 6, that would be called the 6th degree. Okay, these are the key names to remember. Constant, which is just your number value. Linear, which has a degree of 1, so it could be x plus 3. Quadratic is x squared. Okay, it could be 2x squared, 3x squared. Okay, cubic is x cubed. Quartic is x to the 4th. Quintic is x to the 5th. Okay, so these names represent the highest exponent, which is your degree. Okay, these names over here are how many terms. Yes. Nope. You're right. So excellent. These two are not related to these. Okay, they're two separate. Okay. So one thing that I want you to, just before we get to the bottom, is an example which is not a polynomial. Okay, so not a polynomial. Would be something like if I had 3x to the 1/2 or if I had 5x to the -2. These are examples that are not polynomials. Negative exponents and fractional exponents, okay? Those two things are not polynomial functions, all right? They have to have whole number exponents, okay? Okay, so whole number exponents is a polynomial, okay? So now at the bottom, we're going to do the first one together. We're going to classify each polynomial by degree and the number of terms. So what is the degree in 1a? What is the degree in 1a? Mia? Quartic. So it's a degree of 4, which is quartic. Okay? How many terms do we have? 2. So how would I classify that? Binomial. Excellent. So if I was to write this without the number 4, it's a quartic binomial. Degree of 4, 2 terms. Okay? Try B, C, and D. Okay, for B, what do I have? Hannah. Excellent. Cubic trinomial. Excellent. How about C? Go ahead, Rob. Good. Quadratic binomial. Excellent. How about D? Nick? Excellent. Linear It's a linear binomial because we have an x there, okay? If it was just 17, then it would be a constant, okay? So 17x is a linear binomial. How many of you got all three of those correct? Good, you guys. Awesome. So now, we always want to write these in standard form, okay? So it's the highest exponent, as you read it left to right, highest exponent all the way down to the constant. Now, one thing to remember, your signs don't change, okay? You're just rearranging, especially in these two examples. So, which one will I start with? Hannah? Good. So 3x cubed. Then what would come next? M? Plus 3x squared. Good. Then what's next? Hannah? X. And last but not least, minus 12. Okay, so all we're doing is rearranging. How about B? What would that look like? Camilla? X to the fourth. Good. Then what would come next? Kennedy? Good. And last but not least, yeah, plus 4. Good. So, like terms have to have what in common? Think of like terms. What do they have to have in common? Same exponent. Okay. Same exponent. And what else? And same variable. Awesome. Good job. Okay. So now in part 3, you want to identify the like terms. Okay. So, starting with your highest exponent, what am I going to start with first to write this in standard form? Hannah? Good. 5x cubed. There's nothing else to add to. Okay. After 5x cubed, what would come next? What would be the exponent? Hannah? Not 3x cubed. Be careful. Christopher? 4x squared, because we have 3x squared and we have x squared, so we're able to combine those two. Okay, so you're just adding the coefficients. So it's plus 4x squared. Okay, then we have our x terms. Okay, we have negative 2x and negative 4x. So what are we left with? M? Negative 6x. Good. And then last but not least, we have our constant. We have 7 plus 7, which is 14. Good. Excellent. Try B. All right, for B, what do I have? That's my answer. Go ahead, Finn. Perfect. How many of you do you get that? Good. You have your x cubes first, okay, to combine to get negative 6x cubed. X squared is by itself, 5x is by itself, and negative 18. Excellent. Okay. Other two definitions to know is the leading coefficient and the constant term. Okay. The leading coefficient is attached to the degree. So it's the number that leads your polynomial. So it's the first number with the highest degree. So in A, what is our leading coefficient in standard form? What would it be? 5. Good. In B, what would it be? -6. Excellent. Okay, this is your leading coefficient. Your constant is the one at the end without x. Okay, it's just your number value. Okay, so in A, what's our constant? 14. In B? Awesome. Good. Okay, so everything we just did classifies a polynomial. Okay, so when we have to classify, name by degree, name by number of terms, okay, standard form, leading coefficient, and constant. Okay, those are all things that classify a polynomial. Then we get into adding and subtracting, which is just simply combining like terms. You saw this on the last few of Delta Math, okay, where you had to just combine like terms. Just curious to see who was able to do that, okay? So when you're adding, you could just literally drop the parentheses. So if I had 3x squared plus 2x minus 7 plus 7x cubed minus 3 plus 4x squared. All I'm doing is combining like terms and then writing it in standard form with adding. All we're doing is combining. All right, for number 1, what do I have? Yep. Careful. Emily? This is cubed and not squared. Okay. All right, it's okay. Good. 7x cubed plus 7x squared plus 2x minus 10. Okay, so we're just adding. Try number 2. Okay, for number 2, someone I have not heard from yet today. Porter. Good, excellent. Perfect, good. Okay, now 3 and 4 have to do with subtracting. What do we have to do first? Hannah? Perfect. So we have 3x squared minus 7xy plus y squared. In our final answer, we're going to leave it in that form. Okay. Then we have plus 4x squared minus 7xy plus 3y squared. Okay, you want to distribute before you're able to combine. And we're going to keep it in the x squared, xy, y squared form. Okay. What do I get? Liam? Minus what? Be careful. Just be careful of signs. And then it's okay. Be careful of signs. Make sure you distribute that negative all the way through. Yep. Okay. All right. So 7x squared minus 14xy plus 4xy plus 4y squared. Okay. Try 4. Go ahead. All right. For number 4, what do I have for an answer? Tyler. Awesome. Good job. Perfect, you guys. Excellent. Okay. So then, if we have some word problems, okay, in terms of if the length of a rectangle in terms of x, so you're not solving for x, it's going to stay in terms of x. And its width is that. What is the perimeter of the rectangle? So I gave you the perimeter formula. Okay, it's 2L, 2 length, plus 2 width. Okay, so you're adding all the sides around. Okay, so in order to find the perimeter in terms of x, do 2 times 9x squared plus x minus 5 plus 2 times the width. What do you have to do first? Yeah, Camille. Good. So we have 18x squared plus 2x minus 10 plus 6x squared, 8x plus 8. Okay, and we're leaving it in terms of x. Okay. So from here, we're able to combine like terms, and it's going to stay with x. What do I have? Luce? Be careful. Yep, minus 2. Good. 24x squared, and then plus 10x minus 2. Great. Okay. So be careful of your signs when we're combining. Okay. So that would be your answer in terms of x. 24x squared plus 10x minus 2. Okay. Try number 6. Okay. What does our perimeter equal? Tyler. Perfect. Good. Excellent. How many of you guys did get this? Good. Perfect. Okay. So now, when we're multiplying, okay, what happens to those exponents? What do we do when we multiply? Add the exponents, right? So if we have 2 monomials and we're multiplying, if we have x cubed times x to the 4th, what do we end up with? Emily? X to the 7th. They're adding exponents. Perfect. How about in number 2? We have 3x times 3x. Hannah? Perfect. Good. Good. How about number 3? Nick? Perfect. All right, so that's one thing to remember. When we are multiplying, we add the exponents, okay? Now, if we have a monomial times a polynomial, what do? We not cross multiply. Here, distribute. Good. So you are right. I knew what you were thinking. We are distributing here, okay? So negative 5x is going to all 3 of those. So negative 5x times x squared, what do we get? Luce? Good. The negative 5x times negative 2x. Hannah? Plus 10x squared. Yep, because we have negative 5x. Okay. Then negative 5x times 3. Yep, negative 15x. Good. And that's how you leave it. Okay. All we're doing is distributing. Okay. So try 5 and 6. Okay, try 5 and 6. Okay, number 5. What do we have? What do we have? Mia? Not 40. What would it be? 45. Excellent. Good. 10x to the 5th plus 25x to the 4th plus 45x cubed. How many of you guys got that? Perfect. Awesome. How about 6? M? Good. So when we distribute, we have x to the 4th, then we have plus 4x squared, then we combine like terms. Again, we want to finish writing it in standard form. So x to the 4th plus 5x squared. Yeah, Hannah? You distribute the x just to that parenthesis. Yep. So then x squared just carries down. Then you have x to the 4th plus 4x squared. Then you combine like terms. At the end. Yep. No. FOIL is down here. So in number 7, okay, you have 4x plus 1, and then what do you have to multiply by? Negative x squared. So I have negative x cubed minus x squared. Okay, so you're only distributing the negative x squared. Now we combine like terms. Okay, if there is any. If not, we write it in standard form. So we have negative x cubed minus x squared plus 4x plus 1. That's our answer. Okay, questions? Okay. The next part is foiling, okay? Using the distributive property, okay? Yeah. First, outer, inner, last, okay? So it's your first terms. So 6x times 3x is 18x squared. Then we look at our outer. 6x times 4 is 24x. Then inner is negative 5 times 3x, negative 15x. And our last, negative 5 times 4 is negative 20. Then we're able to combine like terms. Okay, so what is my final answer? Emily? Good. Okay. Try 9 and 10. Go ahead. For number 9, what do we have? Anthony, what do you have for number 9? Good. How many of you did get that? Good. Awesome. Okay. Perfect. Okay. And 10. What do we have for 10? Anybody? Tyler. Mhm. It's okay. Take a minute. Do you have it? Yeah, okay. Yep. X to the 5th. Perfect. Good. cubed plus 10x. Awesome. How many of you guys did get that? Good. Okay. And when we have in number 11, binomial times a trinomial, what do you have to do? What do you have to do here? Yeah? Good. So you're distributing. FOIL is no longer being used here because that's for two binomials. But you're still using the process of distributing. You distribute the 3x all the way through. Okay. So we have 6x to the fourth minus 6x squared plus 3x. Then you go ahead and you distribute the 2 all the way through. So then you have 4x cubed minus 4x plus 2. Then you're ready to combine like terms. So what do I get when I combine? Liam? Perfect. Excellent. Okay. So you're distributing the first term, 3x, all the way through. Then the 2x. Then you're combining like terms wherever you can. Okay. Try 12. That's number 12. Nick? Mm-hmm. Be careful. Be careful. Rory? Careful. Mia? Correct. Okay. When we go through, you have 4a to the fourth minus 3a squared plus 7a. Then you have negative 20a cubed plus 15a minus 35. Okay, so just be careful. You have 4a to the fourth minus 20a cubed minus 3a squared plus 22a minus 35 as your final answer. Okay, just be careful with the exponents. Okay, any questions on those? Just two more things we have to do. The next, still with multiplication, okay? However, now with the word problem. Now this is something I would put a major star by. You might see this on test quiz midterm. Okay? So your neighbor asks you to cut her grass. Her yard is 6x plus 3 feet wide and 10x plus 3 feet long. A section of the yard is fenced in for her dog. The dog cage is x minus 2 and x plus 2 feet long. Okay. Write a polynomial expression, so you're still keeping it in terms of x, that represents the total area of the yard. So area, I wrote the formula above, length times width. Okay. So what are the two pieces I am using to find the total area of the yard? Hannah? Perfect. Okay, so that's what you're using to multiply. Okay, so you want to multiply. Your polynomial expression is after you multiply it through. Okay, so go ahead and take a minute and multiply those through. Okay, so what would my polynomial expression be in terms of x? Hannah? Perfect. 60x squared plus 48x plus 9. This is your polynomial expression for the area of the yard. Okay. Now we want to see what is the polynomial expression that represents the area of the dog cage. So what two am I doing here? What two pieces, Mia? Good. Okay. And what would that be? Emily? X squared minus 4. That is your polynomial expression that represents the area of the dog cage. Okay. Then write a polynomial expression that represents the area of the yard you will mow. So what does that mean? Hannah? Perfect. So how I set this up, why do I have parentheses around x squared minus 4? Why do I have parentheses around x squared minus 4? Yeah. Perfect. So the negative is distributed to both x squared and negative 4. Okay. So then we have 60x squared plus 48x plus 9 minus x squared plus 4. Now we're ready to combine like terms. What is the area in terms of x that you will mow? Luz? 59. It's okay. 59x squared plus 48x plus 13 is your final answer. Okay? And that's the area that you will mow. Okay? So the last two things are in terms of substitution. Okay? Last two for today, because we've done a lot. So anytime it says direct substitution, okay, or in this scenario, negative 3x cubed plus x squared minus 12x minus 5 when x is equal to negative 2. So what would you have to do then? Yeah. Good. Okay, so, and we're used to this looking like f of negative 2 in function notation. So that means everywhere we see an x, we're substituting in negative 2. Okay? And this is what I want you to be careful of, your exponents. Okay? Your exponents have to be done first. So we have the negative 3. What is negative 2 cubed? So that's negative 2 times negative 2 times negative 2. Kennedy? Negative 8. Good. What is negative 2 squared? Negative 2 times negative 2. Good. Negative 12 times negative 2. Emily? Plus 24 minus 5. So I'm just going to add these guys. So what would be our final answer? So we're adding 24 plus 4 plus 24 minus 5. Emily? 47. So direct substitution means you are just plugging in -2, substituting in -2 for x. But you have to be careful with your exponents. But there's another way, okay? It's called synthetic substitution, okay? This is going to look very similar to when we get to division, okay? When we get to division, where we are using synthetic substitution. So using the same problem above, okay? We start with whatever x is equal to, -2, okay? That goes on the outside of like this L-looking shape, okay? -2. Then what we line up are the coefficients. So -3x cubed, we eliminate the x's right now, okay? And we just have -3. Then we have 1, -12, and -5. Does you guys see that? Okay? The first process with this is to bring down your first term. So you bring down -3. Okay? Once you bring that down and cross that line, you now multiply. -3 times -2 is what? 6. You bring it back to in between. When it's in between, you now add. What's 1 plus 6? 7, okay? Now we multiply. 7 times -2? -14. We add -12 plus -14 is what? Someone said it. -26, good. Now, -26 times -2 is what? 52, okay. Now, what's -5 plus 52? Is that the same answer we got above? Correct. So you start it with bringing down the first term. Then you multiply. -3 times -2 is 6. You add. Once it crosses that line, you now multiply. 7 times -2 is -14. You add. -26. -26 times -2 is 52. You add. That last box is your answer. So you don't have to worry about exponents, okay? The confusion of exponents, you just have to do synthetic substitution. All right, so we're going to try this last one. So what's going to be, and we got to add something here. What's going to be on the left-hand side? -1. Okay. Now, think of standard form. Do you see anything missing? So we're starting with x to the 4th, which is -2. X cubed is -1. Do we have x squared? We don't have x squared, so we need to put a 0 in its place. There's no x squared term, so we need to put a 0 in its place. Then we have 4 and -5. Anytime you're missing a term in descending order, you have to put 0 in its place, okay? Because it's a placeholder. Okay, yeah. Because x squared is missing. You don't have an x squared term, okay? So how do we start this process? What do we do first? Porter? Bring down -2. Then what do we do? Rob? We get 2. And now we add -1 plus 2. 1. 1 times -1. 0 plus -1. -1 times -1. 4 plus 1. 5 times -5. 5 times negative 1 is negative 5. Oh, yeah. Negative 5 plus negative 5. Negative 10 is your final answer. Okay? Negative 10 is your final answer. Okay. So, we're going to start with the in-class practice. Yeah, Camille. You have to pay attention to directions. It might say direct substitution, which is the previous one, or synthetic. Okay? Most likely I'm going to give you the option of whatever to use, but just pay attention to that. Great question. So you guys are going to start with the in-class practice below, okay? These specific problems, all right? We should have time to go through them. 1, 3, 4, 9, 12, 14A, and 15A. Okay? Yeah. 1, 3, 4, 9, 12, 14A, and 15A. That's for in class. Okay? Go ahead, you guys.